Hello, the topic for today is frequency distributions in histograms, and I'm going to be showing you how to make a frequency distribution and then a histogram from that. The instructions are in your book on page 48, okay? So they have the procedure for constructing a frequency distribution. But let's look at an example, okay? So here is a frequency distribution, and it's just a way to organize data. So here they have the pulse rates of females and males, and they've made a frequency distribution of the pulse rate of females. So they've taken this data and organized it into a chart. Okay, so here you can see that these are the classes. Okay, these numbers, the numbers to the left are the lower class widths. The number to the right are the upper class widths or the upper class limits, and then these are the frequencies. So let's do an example of our own, and you can follow along using these directions right here. Okay, so first thing you want to do is determine the number of classes, and it can be anywhere between 5 and 20, and you can change the number of classes once you look at your data to get convenient values. Okay, so here I have some data, and this is these are the wand lengths for different wands in Harry Potter. I'm a Harry Potter fan, so I thought I'd use some Harry Potter data. And this is just off some website online. Okay. So since I have 27 values, I think 6 would be a good number to, we should use 6 classes. Okay. So the first thing you want to do is calculate the class width. Okay, you want to take your maximum data value minus the minimum data value divided by the number of classes. So in my data set right here, the smallest, the minimum is 8 3/4, and the maximum is 18. Okay. So 18 minus 8 3/4, or 8.75, divided by, I want 6 classes. Okay, that'll give me a class width of 9.25 divided by 6, roughly 1.54. Okay. Now that's not a very convenient number, and I'll put these squiggly lines to mean approximately. Okay, so anytime you see those squiggly lines, the squiggly equal sign means approximately. Now 1.54 is not really a round number. Okay, so let me change my class width to 5. Okay, and once I do that calculation, I get 1.85, which is pretty nice. I can round that to 2. Okay, so you can round the class width. We usually round up, so I'm going to use this one. So I'm going to have 5 classes. Okay, so you start off by writing your lowest class width. Okay, let me make a frequency distribution. So I want to write my class, the frequency. Okay, so I'm going to start off with the lowest being 8.75. And I'm going to add 2 to that every time. Okay, so 8.75 plus 2 is 10.75 plus 2, 12.75 plus 2, 14.75 plus 2, 16.75. Okay, and then these are my lower class widths, and the upper class widths are just going to be the number right below this. So I'm going from 8.75 to 10.74. So now I'm not repeating this number, right? I'm going just one below. So one below that is 12.74, 14.74, 16.74, and 18. So how did I know it was 18? Because it's two more, right? 14, 15, 16, 16, 17, 18. Okay, and I have 5 classes right there. Now I want to look at the frequencies. So for the frequencies, it really helps if you sort this data. Okay? And what you can do is you can plug this data into your calculator, because you won't have Excel, right? I'm assuming you're not working with Excel right now. You can put this data into your calculator in the list. So how do we go to the list? Stat, edit, okay? And just put this data into the list as it is. 15. And if here it says 12 3/4, well, I'll just convert that to decimal. So 12 3/4 is 12.75, 12.25, 10, 9.5, and so on. So give me a minute, and you can do the same and put the data into your calculator. Okay, I've put this batch of data into the calculator. Let me scroll down. That way you can see this as well. So I went ahead and paused the video while, save some space while I was putting these numbers in. Okay? And then it's always a good idea to go back and check to see that these are right. So now that all my data is in the calculator, it'll really help you to make the frequency distribution as if you sort the data. Okay? To do that, you go to Stat, and I want to go to Sort A. Sort Ascending means the numbers are going to go from smallest to largest. Sort Descending means the numbers are going to go from largest to smallest. So I want to sort Ascending, okay? And I want to sort the data in list 1. Now once you hit enter, it'll say done, and it'll sort the data in list 1. So go back and look at your list, and you'll see the data is sorted, okay? So let's go back to our frequency distribution. And I want to now find the number of points, or the number of observations, between 8.75 and 10.74. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, right? So, and this 10.75 doesn't go in this set. It will go into the next class. It does not go into the first class, okay? So I have 11 pieces of data there. Okay, how many do I have between 10.75 and 12.74? That's 1, 2, 3, 4, 5, 5. How many do I have between 12.75 and 14.74? Let me just scroll down a little bit so I can see my list here. So 12.75 is up here. So I have 1, 2, 3, 4, 5, 6, oops, just 6. And then how many between 14.75 and 16.74? It's 1, 2, 3, 4, just 4. Okay. And how many do I have between 16.75 and 18.74? Just 1. And then what you want to do is add up these points. 11 and 5 is 16. 16 plus 1 is 17. 6 and 4 is 10. 10 plus 17 is 27. So I know I've done this right because I've accounted for all my data. I have 27 pieces of data, and that's what I have. Okay? So that's how you do a frequency distribution. Okay. Now, from this frequency distribution, you can make a histogram. Okay? So let me open up a new page right here. And a histogram is like a bar graph, okay, except the bars aren't connected, and it shows you the amounts or the frequencies in a visual way. So 11, 5, 6, 4, 1. So let me go by twos, okay? And I'll go 2, 4, 6, 8, 10, 12, and you want to kind of evenly space them. Okay, 2, 4, 8, 10, 12. And the first one is 11. Okay. Kind of want to make your bars as straight as you can. 11, 5, 6, 4, 1. And then you can go ahead and fill in these numbers here. Right, or you can fill in the middle, calculate the midpoint between these two and fill that in if you want. Okay, but just looking at this histogram, we can tell that most of our data is in the first class, right? Most wand lengths are between 8.75 and 10.75. Okay, and very few are larger than 16.75 inches. Okay. And what we do is we do something called a frequency a curve or a distribution curve, where we just connect the line, just connect the bars, okay? And then you can go back and delete the bars, and here we're getting a curve like this, right? So that's telling us that most of our data is here, very few is here. If I had a histogram like this, okay? And then I went back and connected the curves and made a distribution, or connected the bars and made a distribution curve, I would get something like this, right? And then I went ahead and erased the bars, I would get something like this. This is a very special kind of distribution. We call this a normal distribution, okay? And it's symmetric, so you can see that it's symmetric. And it's not only symmetric, but it has a very specific shape. It's called the bell-shaped curve, okay, because it follows a very specific shape. Okay, we will talk more about the normal distribution later, but when we do talk about the normal distribution and you see the normal distribution curve, know that that's where it comes from. It comes from a histogram where the bars have been erased and the bars have been connected and then they've been erased. Okay, and this tells you that most of the data is in the center and fewer data points are out towards the edge. Okay. But let's go back to our Harry Potter wand length here. Data. We can see that this is not normal and it's not symmetric, right? Most of the data is on the lower end and fewer data is on the upper end. Okay. So if I were to ignore this little point, I would have a curve like this, right? With a tail on the right. This is called skewed right, because the tail is on the right side, meaning that most of the data is on the lower end of the curve. If I had data like this, where most of my data was on the upper end of the curve and I had a tail on the left, this would be called skewed left. Okay. So we have three ways of describing the shape of a histogram or the shape of a distribution curve. You could have symmetric, you could have skewed left, and you could have skewed right. Okay? And remember, with skewness, you always look at the tail. If the tail is on the left, it's skewed left. If the tail is on the right, it's skewed right. If it is skewed right, that means most of the data is on the lower end. Okay? Most of the data is here. If it's skewed left, that means most of the data is on the right, on the upper end. You can let your calculator also graph a histogram for you. Okay, it will do that. You want to go to second, stat plot. Well, first make sure your data is in the calculator, and you don't have to sort it. Okay, you can just put the data as is. Then you go to second, stat plot, and I want to go to plot 1, or any plot. Okay, turn that on, and then I want to go to histogram. Okay, that is a histogram, and my data is in L1. Okay, and it's been put in one by one. So then when I quit this and I go to zoom 9, remember that's zoom stat, this is the histogram it gives me. Okay, this looks a little different than what we've drawn, because here on our graph we had 5 classes. Here they have 1, 2, 3, 4, 5, 6, 7 classes. Okay, and you can tell what each of the bars are if you hit trace. So it'll tell you that there's 11 pieces of data here with a min of 8.75 and a max of 10.29. Then from 10.29 to 11.83 there's 3 bars, and so on. Okay, and note that here they had a class going from 16.458 to 18. There were no bars there, so they actually kept a space for it to let you know there's no bars. Okay, so when you do have a situation where you don't have any observations in a class, you have to leave an empty space, so you cannot just ignore that. So this is helpful. It gives you a visual way of looking at your data. Let us do another kind of distribution, or a frequency distribution. Okay, and I want to look at something called the relative frequency. Okay, now what relative frequency does is, instead of putting the raw numbers, it'll put percents. Okay, so for example, in the first class I have 11 pieces of data out of 27. Okay, and you don't have to actually write the words 11 out of 27. You can just do the calculation, and that turns out to be 0.407, or 40.7%. Okay, then we have 5 out of 27, because I have total 27 pieces of data, and 5 out of 27 gives me 0.185, or 18.5%. And then 6 out of 27. So I'm just plugging this into my calculator. Gives me 22.2% of the data. You want to make sure you round properly, okay? Because if you make a little bit of a rounding error, when you try to total it up, you should, instead of getting 100%, you'll get something a bit off. Okay. So that's 4 out of 27 is 0.148, which is 14.8%. And then 1 out of 27 is 0.037, which is 3.7%. Okay. And then you want to go ahead and add these. So 40.7 plus 18.5 plus 22.2 plus 14.8 plus 3.7. And I get 99.9%. So when you add these up and you get something close to 100%, either 99.9, 100, or 100.01, then that's okay. If you're getting something like 98% or 102 or 90, then you know you've done something wrong. It's a bit off, okay? And you don't even, all you really need is this portion right here. For your relative frequency, you just need this portion right here. Okay. Now let me show you how to do a cumulative frequency distribution. With a cumulative frequency distribution, you want to add each class as you go along. So I started off with 11. In the second class, I have total how many pieces of data so far. Well, 11 plus 5 gives me 16. In the third class, how many do I have so far? Well, 11, 5, and 6 gives me 22. And then in the fourth class, I have 11, 5, 6, and 4, which gives me 26. And in the last class, one more, 26 plus 1, gives me 27. Okay, so that is a cumulative frequency distribution where it shows you how much more you're adding in each class. So I've pretty much shown you the frequency distribution, a relative frequency distribution, and a cumulative frequency distribution. Okay, and you know how to do the histogram, you know all about normality, symmetric, and skewness, and how to do this on the calculator. Okay, so I encourage you to do the practice problems in your book. The odd numbers have the answers in the back. And if you have any questions, feel free to send me an email, give me a call, or stop by.